In the second tutorial of this chapter, we are going to continue with the same objective, that is to calculate an estimate of the gradient of a tangent to a curve. For this purpose, we are going to example 1, page 113. The points shown on the curve with equation y equal x squared are O 0, 0, A 1, 1 over 4. And we can say now something, that these points are found by substituting directly in the equation. We already know the equation is y equal x squared. Then for x equal 1 over 2, then y is 1 over 2 squared, that is equal to 1 over 4. Therefore, the point A is 1 over 2, 1 over 4. And similarly, all the points B, C, and D are found in the same way. We can see these points are on the curve A, B, C, and D. Now, part A, we are asked to find the gradients of OB, AB, BC, and BD. These points are on the curve, and we have a tangent at the point B. Then, in order to find the tangent of B, we are going to find the equation, the gradient of the chords AB, BC, AB, and BD. Let's start with the first gradient, which is the gradient of the chord OB. We know already the gradient is the difference in y divided by the difference of x. That is, for OB, then y2 is 1 minus 0 divided by 1 minus 0, 0. That is equal to 1. Then the gradient of OB is equal to 1. If we go back to the example, it's already solved and they already found the value of the gradients. For the gradient of the chord AB, then it's equal to 1.5. For the chord BC, the gradient is equal to 2.5, and for BD, the gradient is equal to 3. We can observe that the chords are steeper at BD, and the gradients are larger as you move along the curve. As we are moving upward in the curve, then the gradients are going to be larger. As we observe for BD, as the point D is on a higher level of the core of the curve, then the gradient is larger. Here we can see the gradients of all the chords. OB is 1, AB 1.5, BC 2.5, and BD 3. As we are going up on the curve, then the gradient is getting larger. But in part B is asking us, what do you deduce about the gradient of the tangent at the point B? Then at the point B, what is the tangent? We said before that the tangent or the gradient of the tangent line at the point B is equal almost to the gradient of the chord that is closest to B. But we have the gradient of AB and the gradient of BC. Then we can say that the gradient of the tangent B, that is between AC, is going to be in between the gradient of AB and the gradient of CB or BC. Therefore, we can say now that the gradient of the tangent at the point B is between 1.5 and 2.5. The gradient of the tangent at B is less than the gradient of the chord BC, but is greater than the gradient of the chord AB, as it is in between. That's why we are saying it is in between. Now, if we try to zoom in on this sketch for the parabolic equation y equal x square, as you can see. And if we try to zoom in more or magnify the area that is mostly around the point 1 1, which is the point B, we can say that we are almost having a straight line and is close in gradient to the tangent at the point B. Now zooming in, magnifying around the point 1 1, that is the tangent point, we can see the line is going to be almost as a straight line. Then seeing this curve almost as a straight line is going to make it easier for us to find the exact tangent or gradient for this tangent line. Therefore, we can say if we take another point that is close at this to this point B, we can take, for example, the point 1.05 and 1.1, and this point is very close to the point B, that is 1 1. Now finding the tangent or the gradient for this point or this line B and the other point is going to be the difference of y divided by the difference of x, 1.1 minus 1 divided by 1.05 minus 1. This is equal to 0.1 divided by 0.05, and this is equal to 2. Then the gradient for the tangent is almost or exactly equal to 2. And this is going to help us find always the gradient of the tangent of the equation y equal x squared when the point of tangency is 1 1, and it's always going to be 2 if we are asked in the future to find the gradient for the tangent line at the point 1 1 for the parabola or with equation y equal x squared, then it's going to be 2.